Hello there. This is the Alex Manassa, and the AmeriChete lives on, right? If any of you have not watched the previous videos about the AmeriChete, I'm taking a gigantic cold steel machete. It's like 24 inches long, double-handed machete, and I'm going to put LEDs on it so that when I slash the machete, an accelerometer detects the slash, and using persistence of vision, I just make a nice light show, maybe make the American flag, something like that. Something fun. All right, now, if you haven't seen the last videos, I suggest you do. In those videos, I selected this LED. This is an RGB LED. Yeah, go ahead and open it. There we go. Very cool. Firefox is opening on the other window, of course. There we go. This is from Seoul Semiconductor, straight out of Korea. All right. And that is what this guy looks like. It's got the, I'm going to guess this is RG, or, actually, I don't know which one is which. There's an R and there's a yellow. There's definitely not a yellow in this thing, right? So maybe RGB, and then, oh, the white might be the one behind the yellow. Doesn't matter. I'll find out, I guess, when I bring it in. Easy pinout, though. Come on, get the taskbar out of the way. There we go. Pinout is down here. You just got your anode and cathode for white, green, blue, and red. So the white is going to give us a little extra brightness without washing out too much of the color, so you can get some more oomph without, you know, sacrificing too much there. This is a Mosfet, which is called an it says obsolete, but I don't think it's going to matter that much because I can still get the quantities I need. There's like 1,000 of them in stock. I only need I need about 100 of them, which is going to cost me about $10. All right, so a real big ticket item, right? That LED was about 1 amp, was rated to 1 amp. These MOSFETs can handle 1.4 amps. These are N channels. They're going to be shunting the cathode down to ground, allowing current to flow. Very cool. Easy peasy. I'll need some current limiting resistors that can handle the wattage, but we'll get there. And this guy right here, I think is going to be my microcontroller in charge of driving this guy. This is a PSOC 4200 family, so it's going to have plenty of features on it. 48 megahertz processor, Cortex M0. It's checking all the boxes. But really, I need it to be fast, have good interrupts. And I think that digital system, those UDBs, Universal Digital Blocks, those are going to help out quite a bit. I'll explain what those are in another video when I get down to the firmware, right? But I got to make a footprint for this guy, and it's going to be a big task. So I'm probably going to record it, and then I'm just going to put that segment into fast forward. But this is about $5 in single quantities. It's probably about the quantities I'm going to be buying. I might buy like 2 or 3 of the chips just in case I screw up the soldering. But they're not rocket science. All right? You can't really mess them up unless you start messing with fuses. I also shopped for an accelerometer, and I came up with this guy. This is a Kionix KXTJ31057. All right? It has got a XYZ axis, plus or minus 2, 4, 8, or 16G. This is going to help me measure the acceleration of the blade of the machete. If I bring over my whiteboard in any minute, okay, we're going to take our machete that's going to look something roughly like that. There we go. Here's our handle. A little grippy grip there. There we go. Something like that, right? We are going to put a strip of LEDs all the way down. It's about 25 of them. This is a 24-inch blade, so I think that's going to be about an inch or so apart. I don't know. I might experiment with packing them in different densities. It's going to be a lot of LEDs, though. As I swing past, you're going to have the accelerometer, which I'm going to put on the tip so I get the maximum amount of acceleration. And that's going to be the A vector. A vector is always in the direction of the swing. So all I got to do is take that A vector, right? And I got to do me an integral and another integral. And that acceleration as a function of time, dt, or d squared t, whichever one you want to note it as. All right, so this bad boy right here, that'll get me the velocity, v of t, the velocity at any given time. And then this guy right here, it's going to give me x of t, which is the position. This is the one I want. I want the position because I need that persistence of vision system to give me the timing when I should turn on the LEDs and turn them off again, right? Okay. So we're going to experiment. I really like the fact that this chip design has options for ranges. That's going to be really, really helpful. It's got a 12 LGA 2x2 millimeter package, which is going to keep things pretty useful. Like that's a good small package. That's what you want. And the fact that it's X, Y, and Z means I don't have to stress about what position I put the footprint in. One of those directions is going to be where I want to be. All right. Now I really only need the one acceleration direction, but it seems like when I was shopping for this, the price was it's like you don't have to really pay extra for the extra two axes. In fact, if you just get it seems like if you buy the X axis, you get the Y and the Z axis for free. So we got to take a little bit of stock because we need to, and I'm launching it now, design this guy in KiCad. Wait a second, it's already running. All right, so here's my sandbox project. I don't want that. What I do want, I want a new project. Of course, it puts everything in the other monitor. Okay. All right, PCBs. I'm going to call this AmeriChete. AmeriChete. All right. Come on then. Open the folder. Jeez Louise. It's like I'm pulling teeth in here. AmeriChete. I think I could do this in one board. I don't think there's a need to do this in multiple boards. We'll see. All right, let's get right into the schematic. Of course, it puts it on the other screen again. Oh, it's having a schwitz. It's having a schwitz. It's having like a crash moment. What is it doing? Open source software. Oh, look at this. What a travesty. All right. You get what you pay for. Yeah, no kidding, you're not responding. There we go. Opens right up. Open project. Do you even remember the other project? Uh-huh. And then I tried to open a schematic, and then it all went to hell. Awesome. I'm going to go fix this. I'll be right back. And we're back. Okay, that was a stupid adventure. So KiCad just does not like using dual screens. It would just make parts not work. Let's see if I can show. Here we go. It's my desktop. There's me into infinity. I would go to place, symbol, and then I'd click, and just nothing would happen, right? That's exactly what happened. It was the stupidest error I've ever seen. KiCad just does not know how to handle dual screens, which is ridiculous to me because I don't know who doesn't use dual screens. Absolutely stupid. Absolutely stupid. Unacceptable. Unacceptable. Whatever. We'll soldier on. It's free software for a reason, right? I guess. I don't know. And don't tell me it's because of my setup. I just use an old Windows 10. There's nothing special about my setup here. All right. So let's go ahead and find an LED. Let's make it RGB. Yep. Ooh, this one could fit the bill. I mean, I know this is like specifically for a Cree, but it has all of the, it has the parts we need, right? It's got the in and out. It's got the cathode and anode for all these. Let's see if we can do better though. Ooh, with graphite. Fancy. Oh, here's another one. This works. And it doesn't have those weird Schmidt trigger or whatever those diodes were. I forget what those were. Let's see if we can do one that's more generic. Nope. All right, so that's it for LEDs. So I'm going to take this high brightness tricolor RGB LED, which SMLV. Okay, that's interesting. I just want a symbol. I just want the symbol, right? Okay, so 1 to 6, 2 to 5, 3 to 4. We're going to. I had to restart my computer to try and fix this issue with KiCad. So let me open up my stuff again. All right, first thing to do when you're creating a schematic is making sure that the parts you're using have the same pin numbers. The schematic doesn't really matter except for the pin numbers, the name of the part, like the reference designator, you know, if it's R1 or U1 or whatever, and the where the connections are going, right? So Now this thing doesn't have a pin out necessarily. Yeah, this thing doesn't have a pin out, so it's up for us to determine the pin numbers. But it would make sense from top down. Yeah, from top down you'd have... Okay, so arm... How do I want to do this? This is flipped backwards. So on the A side here, we'd have W plus, W minus. Okay, so let me... How do I want to do this? Tell you what, let's grab a capture of this. Okay. We're going to slap that into the whiteboard. What is this? Oh, it's a vector of the AmeriChete. Fair enough. That's a little small, but we'll make it work. There we go. That's much better. Okay, so I'm going to go ahead and write on this guy. Okay, we've got... actually, let's get a little tighter in there. My handwriting's not that good. Okay, we've got W plus. We got W minus. We've got G plus and G minus. Down on the bottom, we've got R minus. We've got R plus. Can't really see that. Let me put that in red. And you've got B minus and B plus. Okay. And I know it's a little arbitrary, but we can say this is pin 1. That's 4. 5. And then 8. Okay. So we're not using... Oh man, shoot. We're not really planning on using the white. But I think we're going to have to modify the part. I forgot about the white part. So pin 1 is W plus. Okay. I'm going to have to keep referring back to that. Yeah, I got to get something else. Let's see if we can find a different LED. If not, we're just going to put something as a placeholder. Because it really doesn't matter what the part says it is here. It only matters that it has like a D or a U1, like this number right here. It has a D question mark at the moment. It matters what that is, and it matters how many pins it has. All right, so these are all like common cathode, not into that. That means you can't control the... Well, I guess you could control the brightness individually still. But I'd really like something that has... Oh gosh, that's a lot. It's a bar graph. I mean, if it had 8 pins, I'd take it, right? Tut, 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 tut. No. Nope. Yep, I already been through these. Okay, so what I'm going to do is I'm going to take the... What is it? SMLV... N, and I'm going to copy it. Where'd it go? Yeah, that's the one. I am going to pull it up in the editor here. I'm just going to type this in so I don't have to find it. SMLV. All right, cool. I want to duplicate this part. I'm going to rename it. I guess you gotta edit the symbol to rename it. Okay, so now I'm editing the symbol. So I went into the library editor. That's where I am right now. And the part number for this guy is... So this is my LED from Sol. Perfect, that's good enough. Okay, so you are gonna be that. I W. Rock on. So now we just need to duplicate some stuff here on the inside. So there's a little bit of artwork going on, and we gotta expand this. So I'm going to see if I can select this and do a drag. Drag rectangle edge. That sounds pretty good. So each of these is 1, 2, 3, 4 blocks. So I'm going to add 4 more. 1, 2, 3, 4 blocks. Okay. Cool. All right. Now we got to grab this symbol somehow. Don't know how to do that. No idea what I'm doing. Okay. No, can't. I'm trying to copy stuff is what I'm trying to do. Move. Okay. All right, no, I can pick that up. What the heck? Why don't you let me copy it? All right, I'm gonna have to draw it wholesale just from the beginning. That's okay. This looks like my guy. Come on. Add lines and symbols. Okay, cool. So let's go ahead and add these new pins just so I have something to anchor to. Let's call this... I think it's going to get really mad at me if I duplicate the pin number. Just call it 4. Let's see if it gets really mad at me or not. This is 1, 2, 3, 4. Okay, so I need to go 1, 2, 3, 4. Okay, well that didn't work out. Let me let me grab that. All right, let's see if I can do it again. Okay, okay. Oh no, it's got. Oh no, it was right the other way. Dadgummit. All right, so I just need to move it. Aha. Okay, okay, this is actually making some sense now. All right, I'm gonna go ahead and add another pin. Luckily that worked out. So I don't know why you can't copy in this, but it just won't let me copy in this. So it is what it is. I'm gonna call this 5. 1, 2, 3, 4, 5, right? Wait a second. Let me make sure I'm doing this right. When in doubt, check it out. So pin 1 to 2. Okay, so it's gonna 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8. So this is really gonna be pin 7. 7. And if it's going to be pin 7, that means it's going to be B minus and B plus. So I'm going to name it B minus. I like to keep all the minuses on one side though. Yeah. So let's rename this as pin number is going to be... Am I creating a new pin? No, I want to edit this one. Silly. All right, so 8. Sorry, 8. Pin name is going to be B plus. So on these symbols, since all of these symbols are completely symbolic, you could put the pins in any order that you want. Make it whatever is easiest to draw. You're gonna make your life a lot easier. Okay. On the other pin here, which I'm gonna put right there. Let's just go ahead and make this B minus and make it pin 7. Awesome. I wish it would show. Rotate this. Kind of wish it would show the... Oh, I don't want to do that. Sorry, I'm losing my train of thought here. No. Okay, so you gotta double click it to terminate whatever mode you're in. Okay. So I gotta click here. No, click there. No. All right, double click. You gotta really double click it. Cool. Okay. Yeah, and so what they do here is they just, instead of putting the pin names, they just put BRG. That's fine, I guess, but we're gonna do it a different way here. No, actually, you know what? I like their way. Let's do that. Okay, electrical type. I'm just gonna make this passive. I think this only affects. I don't know what this affects actually. I have no idea what this will do. All right. So, anyways, I got B up here. Well, that's too bad. I'm gonna rename it white. And I'm gonna make this pin 2. So this is gonna be. Oh, it's got BKs and a blue cathode. I'm gonna make this white minus. Sorry, I do it my way. White plus. All right, so 1 to 2 goes from positive to negative on the white. Very good. All right, so 3 to 4 should be green. So first off thing I'm gonna do is I'm gonna can I grab that? Yes. White. White. There we go. Next one is gonna be green. Let's do green. So I'm gonna take this R, I'm gonna turn it into a G. This pin 2 is gonna become a 3, and it's gonna go from 3 to 4. So we're gonna make this 3. I'm gonna just make this G plus. Here is 4, 4, G minus, rock on. And here in this last one, oh sorry, I got 2 more left. So this G, so I did 1 to 2, I did 3 to 4, 1 to 2, 3 to 4. So here is 5 to 6 is gonna be R minus, R plus. So we're gonna do a little bit of switcheroo here. So it's going to be pin 6, and that's R plus. And over here, is going to be 5, and it is going to be R minus. And I'm going to switch this guy over to an R. Oops, that's a lowercase r. There we go. All right, and I believe I already made this one 8 to 7. I need to go ahead and add a letter. Let's see if this aligns up. Ugh. And what was this one? This one's got to be blue, right? I need to change my grid size. Place, graphical text, zoom in and out, units, grid settings. There we go. Make this like 25 mils, please. Okay. I need to move you. That looks pretty good. I like that. Okay, very cool. And this is in the way now, so let's move this down here. All right, very cool. Now we've got a... also, these guys are not thick enough. I know I'm being kind of a stickler here. Oh, and I didn't put the... All right, so when in doubt, just copy. Your teacher told you not to do it. I'm telling you to do it. If the answer's sitting in front of you, no one's going to blame you for just copying it. Right? In fact, I'd consider you crazy if you didn't. Looks like we've got some thin lines here. Oh boy, I don't know if I can draw that. This could be ugly. I need to change my grid size. Why do we even have a large grid size? I guess it's to keep things in line. Let's change it down to 5. That feels pretty good. So it's about 2 clicks from the edge here. So if I go to the very edge, okay, 2 clicks. If I'm off, oh God. If I'm off, I apologize. Sure. 1 goes straight down. Other goes straight over. And you gotta terminate with a double click. Alright, see? Pro. Now if I'm off, don't tell anybody. I wish I could just I wish I could just grab the stupid thing and copy it, but it doesn't want to let me. I don't know. Alright, so this is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. No. 8. It's 8. Let's call it 8. 1, 2, 3, 4, 5, 6, 7, 8. All my years in college are paying off right now. This is what it's all about. Oh, those crosshairs feel so good. All right, there we go. At least if you're not entirely lockstep with everybody else, you can at least be lockstep to the person next to you, right? That looks kind of like a pretty good facsimile. I think I faked it pretty good. I almost can be a Chinese engineer. All right. Can I save this? I don't want to. Can I save this? Please let me save this. Please don't make me do this again. Save as? Sure. Oh, no. Oh, no. You know what? I'm just going to put an _1. You sons of guns, you sons of bitches. Oh, no, you already... Okay. All right, I don't need both these then. It was already... All right, what? I don't know why that's asterisked, but whatever. Okay. Scaring the crap out of me. All right, now, always check. So, pin 1 to 2 is white anode cathode. Pin 1 to 2 is white anode cathode, and that's from here, anode cathode. Okay. Okay. Pin 3 to 4 is green anode cathode. 3 to 4, green anode cathode. Very good. All right, green. Pin 6 to 5 is red anode cathode. Okay, 6 to 5, red anode cathode. And pin 8 to 7 is blue anode cathode. So pin 8 to 7 is blue anode cathode. We did it. We did it. All right. Please be saved. Please be saved. Why is there an asterisk? Like, the asterisk usually means it's not saved. Is it because I haven't saved the library? I don't know. Yeah, sure. What do you mean I don't have write permission? You're killing me, man. I'm just gonna put custom.lib. How about that into AmeriChete? Sounds fair? I'm saying it's fair. Let's all just say it's fair together. You can't edit this. It's driving me nuts. Driving me nuts. All right. So let me make sure my stream is still up. All right, it appears to be. I'll review this footage and find out it's all screwed up. I would cry. I might cry a little bit inside. Okie dokie doodly. I need to add. Did it even add my thing? Is there a custom library here? Okay. Just checking my phone. All right, let's just select with browser. You drive me nuts. I need to import a library, I think. Okay. How do I... All right. I need to go to my library. Create, delete, edit symbols. Okay. Add library. That's what I want. Custom lib. Just as this project. How about that? Did you add it? Did you do it? There it is. Wait, what? I'm a little confused. So I guess it... All right, well, I guess it added... It didn't save my changes. I knew it! I knew it. You sons of guns. You screwed me over again with your damned asterisks. Ah. All right, maybe I didn't load it right. How did you not save that? That was so explicit. KiCad, you're absolutely killing me. You're absolutely killing me right now. I hate you so much. Maybe if I can just change the file names. I don't know. I hate you so much, KiCad. You've already screwed me over so much. Import symbol. Oh my god, I hate you so much. Add library. Yeah. Just project. Custom 2, electric boogaloo. Why is there so much stuff in this? Oh, wait, never mind. It did save it. What the hell? Why is all this stuff in custom? That's okay. Why aren't you saved in custom? Oh, no, it is. All right. Well, all right. Well, I feel like a big dummy. Huge idiot. Here I am creating all these extra libraries. Okay. If I'm going to break something, I'm going to go put it back. Okay. So let's go ahead and rename those back. Oh, I feel the blood rush out of me. First time you use a new software, and it's even a little bit unclear whether or not you saved it properly, and it closes. You close something and you're not sure if you saved it. It is a nightmare. It is like the scariest thing in the world. I hate it. But we're past that hump. We're past it. I'm going to go ahead and get rid of this library if I can. Okay, maybe I can't. Whatever. All right, I guess I'll have that just cluttering my library browser forever. Worst things have happened. All right, cool. Can I? Well, that's great. All right. Well, I'm just gonna go ahead and put you in my project now. Okay, get out of my face. 100% disgusted. 100%. What is? I should have named the library AmeriChete. I think it combined with something that was already there. Created this mess. Okay. Jeez, all that for a freaking LED. Well, the good news is, once we do it once, we can do it 1,000,000 times. So I need 25 of these. So I don't know if you guys are counting. I'm going to give it plenty of room. 1, 2, 3, 4. Oops. Didn't mean to scroll there just now. Awesome. Come on. Okay. what I'm hoping to do is grab that and just hit, nope, okay. It won't let me do that. Can't just select them all and then like copy. There we go, copy block. Oh, Control C to copy block. All right, okay. So that's 1, 2, 3. Well, I need to tell you what I'm going to do. I'm going to make one set of the full circuit. Because what this full circuit is going to be, it's going to involve Mosfets. So start placing some FETs. Enchant. It's going to be in discrete. Maybe driver FET. Okay, here we go. All right, okay, driver FETs. Okay, that's really complicated. Don't need that. Can I just have a regular old FET? Nope. 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 All right, this is a waste of time. Good lord, there's a lot of driver FETs. Okay, driver. I might want device and the device library. So the device library is where all the sort of generic stuff is. All right. Microphones, memristors. Those don't exist. Yeah, those don't exist. They're trying to be cute. I don't think they exist. I'd like to buy one. Oh, for frick's sake. You don't have a... Oh, wait. Q qual NPN. Alright. Why is it called Q dual? Why is it Q? Okay, do you have N? There we go. N channel. Well, that's an IGBT. I don't want that. I don't want to get weird with this. Okay, I could take an NJFET symbol. I mean, that's nothing wrong with that. And Mosfet. There we go. And Mosfet. Okay, cool. All right. Now, why is it different? Gain. Okay. Don't think it matters. Drain, gate, source. 1, 2, 3. All right, let's go to the Mosfet datasheet. Because I believe we got a weird looking one. We got like a SOT. Now I doubt that this is in the catalog already. Because it is 1, 2, 3, 1, 2, 5, and 6. 1, 2, 5, 6 are the drain. 3 is the gate. And 4 is the source. Okay, well, that's weird. We're probably just going to have to reassign some stuff. Yeah. Okie dokie. I was hoping to make this easy. But we're going to have to do so much custom stuff, it's not even funny. I'm just going to type Mosfet in. Driver FET. Nope. Okay. How about NPN? Oh, sorry. N channel. Actually, let's go on a limb here and see if we actually have BSD 316. I mean, it's highly unlikely. Yeah. Do we have any BSDs? Nope. That's not gonna do it. That's not gonna do it. All right. I gotta go find it again. It's always fast the second time. QNMOS. Yeah, load it up. Save copy as. I might as well just grab this whole part number and just stick it in here. Save it as, and I want you to put it in custom. Oh, I see a problem here. Ugh. Alright, we'll just put it in custom for now. Cool. All right, so on the input, I'm going to put pin 1, 2, 5, and 6. So it's 1. All right, and the input is going to be on pin 3. So let's go ahead and get that accurate. And on the drain, that's pin 4. Oh, I'm sorry, source. Sink, whatever they call it. All right, cool. All right, that'll do, I think. I mean, it'd be nice to go ahead and reassign those other pins to connect, but I don't think it's necessary. But I'll think about it. This is BSD 316. Pretty sure I see that on signs at wrestling matches. Just kidding. Where is BSD 316? Okay, we're getting a workflow here. Yeah, this is why I made. Yeah. Oh man, they're just spaced out enough to screw this up. Okay, we're gonna get a little more clever. Yeah, how about that? It's important to be aesthetically pleasing. Oh wait, I'm making it as if it's going to go into the gate. It is not. All right, so oops, copy that, copy that, copy that. I might go ahead and just make an experimental board that just has one of these or a few of these on here that I can test with in my lab, so I don't end up, you know, blowing 25 LEDs, although I guess I might as well try for the final circuit board from the get-go. I don't know. I just feel a little bit better if I didn't waste a ton of... I can either waste circuit board and try not to go for the gold. Oh, look at all this. Unnecessary. Can I see a ground? Thank you. This thing's a chunky one. These are some chunky FET symbols. Yeah, I tell you what, let's it's real weird. Okay, so you've got to... I probably want to drag, actually. See, I'm moving them. There's a difference between move and drag. Yeah, drag is G. Okay, so drag will grab everything with it. Okay. So oh, wow. Got both of them. Trying to make it pretty. I'm trying my best. It's a real challenge right now. Let's just give myself a ludicrous amount of room. How about that? There we go. Hey, this doesn't look terrible. Move these letters. Move the reference designator. Move this ground symbol. Field value. Okay. Move the field value. There we go. Key. Okay, that looks good. All right, we got a little array going on here. I'm going to go ahead and copy this ground symbol, plop it down here. Very cool. Now, if I'm going to do a little prototype board, I guess I might as well just make it the easiest little prototype board in the world. And take all of these lines and just send them out to a connector. So I got 1, 2, 3, 4 in, but I'm also want to put power and ground on here as well. So I got 4 signals, 1 power, 1 ground. Let's go ahead and do that. Before I do that, let me just grab this guy. Oh my gosh, I hate the auto scroll. I hate you so much, auto scroll. Okay. So N MOSFETs let you shunt things to ground so that current can go down, right? I'm just checking my feed, make sure everything's okay. All right, just see if I'm talking to myself. All right, place power. So it lets you shunt current down to the ground. Power port, which means, now it doesn't really matter which one of these I choose, by the way. I can choose any 5 I want. VD, I guess, I don't know. Why do they come with so many names for things? Here, VCC, that's what I want. And I'm going to want to place some resistors. So N MOSFETs allow you to pull to the ground. So it's like you're throwing a switch, and it just allows the electricity to make its way to earth, ground, or whatever ground you've chosen. There's nothing magical about it. Symbol, let's go ahead and we're going to go into the device library, and we're going to grab a resistor. In fact, I think it's just called RUS. Yeah, the US resistor symbol. There's a there's a European resistor symbol as well. Okay, grab that guy. Yeah, all right, I'm gonna leave well enough alone down there. I was tempted to try and optimize it more, but sometimes there's a thing called over-optimization you don't want to do. Alrighty. These guys go up here. These guys go up here. There we go. Okie dokie. What else? So we got our current limiting resistor. Are these R's up above? We can also send out these. Here, let me go ahead and pull a connector. We're also going to want some sort of current limiting resistor going to the gates of these MOSFETs. Mostly it's just to try and give you an option to have some sort of noise suppression, so you don't have too much inrush current. You don't have to do it. You can probably survive without it, but I try not to. There's a capacitive load at a MOSFET gate, and I don't like to just slam my MOSFET like that. Your MOSFET's not going to live very long if you do that. There we go, generic connector. That's what I want. I love generics. So I'm going to need 6, right? 4 signals and 1 power and 1 ground. Awesome, cool. I'm going to mirror this. So I'm about to place it. I'm going to go ahead and just mirror it horizontally. There we go. Okay, I don't know what x-axis you're looking at, but I feel like I'm driving in like an old Russian car sometimes on this thing. All right. I don't mean that to be too much of an insult, but it's kind of an insult. I'm going to throw some shade. But, hey, it's free, so can't complain too much, although I will complain a little bit. Okay. All right. And there we go. Now let's go ahead and connect our ground. I'm just going to put that there. Nope. Yep. Grab VCC. So although VCC is designated as being a voltage source, you need to actually give it to a connector or a real source of voltage. In this case, it's just going to be a connector. I'm going to put this as a header. Let's go ahead and do AmeriChete. I probably shouldn't name this AmeriChete. Maybe I should have called it AmeriChete Prototype, but I'll make AmeriChete Full Scale or something like that just to differentiate it. I don't know what these resistor values are going to be, so if I give this thing a nominal of 20 volts, right? So 20 volts and voltage divided by current is going to be resistance. V equals IR. You can divide both sides by I and then get R. Okay, so 20 divided by If I got 20 volts and I want 1 amp, I need to put 1 ohm here, obviously. But let's say I want to get a little less than 1 amp. So 20 divided by 0. I don't know. Let's go for 100 milliamps. All right, so this needs to be 200 ohms each. That was 2,000. That was 2,000. Got a little frisky with the trigger there. Also, these are ugly. If you want to be happy for the rest of your life, you need to make a circuit pretty. Oh. All right, there we go. That's a pretty circuit right there. Now let's go ahead and assign all these reference designators values. They all have just question marks at the moment. So there's a tool. There's annotate schematic. You can sure. I don't know. Okay. All right, whatever. I didn't know it annotated these grounds and power planes. It doesn't make any sense to do that, but okay. All right, so now we've made a schematic. This is a fully functional schematic. All we got to do now is to make it into a circuit board is to assign it footprints. So let's do that. Oh, good, the footprint editor didn't make the thing crash. Yay! Alrighty, look at all these connectors, by the way. Good lord. I love it. I just love lots and lots and lots and lots and lots and lots of choices. It's just super great. Here we go. Pin header, 2.54 millimeters. 2.54 millimeters is 100 thousandths of an inch, or 0.1 inches, I think. Yeah, it is. Now I want to check. See, I have no trust in myself. All my years on Earth have done nothing but make me doubt my sanity at every turn. I want to go from millimeters to inches, please. 2.54. Yeah, what? That's the most elementary, dear Watson. Come on now. Where's your confidence? I lost my confidence in the war. All right, so these are footprints. These are actual circuit board footprints. This is going to go in place of the symbol once we turn this thing into a circuit board. Now, this particular footprint right here shows 6 pins, and it's going to go, and it's the silk screen here, which is in this sort of bluish green, is showing header pins that are bent over into a right angle. That's fine and all. We don't really need that. Vertical is fine. I don't know what these are. Okay. All right. Well, that's cool, I guess. Vertical. Let's make it happen. Love it. Awesome. Ep.5 FOB. Now, the problem with that is I don't think I have a footprint for that one, so there might be another video. I just don't have the patience right now to sit and make a footprint for this. I don't even know if this thing has an official footprint. 2318. What does that even mean? Okay. Yeah, that's not true. What does that even mean, 2318? Well, there aren't that many here, so I'm just going to go through here. And do any of these even have 8 pins? Hyper doubt it. My doubt level, I'm pressing X to doubt right now. Some cool footprints, though. All right, that's going to be another video because I just don't feel like doing that right now. Footprints are my least favorite part of doing this. I will exit that out, though, to let everyone know, or let the computer know that I've not chosen anything for it. Resistor footprints are easy to pick out because they're all standard. So all I got to do is go down to the resistor, SMD. We do SMDs around here because I'm a man of class. But let me do a quick power calculation before I just jump into SMD land. Scientific. So I want 20 volts dissipating 0.1 amps, right? So the power through that is going to be V times I, so that's 20 times 0.1, so that needs to be 2 watts. 2 watts. Holy smokes. Oh, wait, that's not dissipating through. Okay, wait a second. No, that's not. That's if the resistor was the only thing on that 20 volts. That's incorrect. So the actual voltage across the resistor can be found with I squared R, right? Because V equals, if P equals, here, I'll actually show you what I'm doing instead of just rattling off symbols. Here we go. All right. Always lose my pencil. So power of a component equals VI, kind of by definition, right? But you can substitute that V, which is going to be the current through the resistor times R, the resistance of the resistor. You end up getting P equals I squared R. This is better if you're actually trying to do the amount of power dissipated in a resistor, because this doesn't, like 20 is not actually the voltage across that resistor. That's just not true. We're gonna lose some voltage to the light, so that's just not gonna be true. Okay, and that's going to equal, let me just, there we go. That is going to equal 0.1 times 0.1, that's the I squared, times R, which is 200. Oh, it's still 2 watts. What? I'm going to press the doubt here. Okay, so I know the voltage drop across that LED is going to be about 2.5 volts. Okay, so it's actually going to be this much times 0.1. It's still a beefy, yeah, I still want to get at least 2 watts. Okay, I didn't want to admit it, but it's going to be more than a watt through each of these resistors. That's a little insane. It's a little too much. Digikey.com. I might want to do something about that. That's really high. Oh. All right, let's think. Let's think. Resistors, current sense, that's great. Let's just do chip mount, surface mount resistors, see what we can do. I doubt it's going to be cost effective. Yeah, it's probably one of the reasons why people use current sources for these, because then you can get a much more efficient use of the LED, so you're not dissipating so much power across the resistor. But I'm not really going for efficient. This thing's going to be a real flash in the pan. Current sources are super expensive, at least relatively speaking. Here he is, watts. Sorry, I was in another place for a second. Okay. We still got a decent selection. Let me just hit normally stocking. So we still got 9,000. The resistance I would like to hit would be, what did I say, 200 or 20 ohms? I think it was like 20 ohms, wasn't it? 20 volts divided by 0.1. No, it was 200. Okay. I'll go anything from 200 to 300. Oh, you know what? Let's go from 300 down to like 150. There we go. 347 items remaining. We have a prayer. They're not the cheapest thing in the world, but we'll see. Thick film. Thick boys. Let's say I want 100 of them, at least. This usually makes the price go down like a ton. If you want to buy one resistor, it's really expensive. If you want to buy 1,000 resistors, it's like a few pennies more. It's probably just for the trouble they have to go through. All right, 12 cents is going to be our guy. And, well, at least it's active. It's a 2512. Let's see if, yeah, 6432 metric. That's going to be interesting. It's a big boy. It's a big boy. All right, let's see if we've got that. And we've got a couple alternatives that are in a similar price range. I'm really curious to see if they actually have this, because I don't think they do. Well, maybe they did. All right, so what was that package again? That was 2512. Oh, yeah, we do have that. Huh. Ha ha. I don't know why there's a difference between hand solder and not hand solder, but okay. I don't really know what the difference is there. I don't know. I guess I'll pick hand solder. I always do a size check with these. I'll print out the entire circuit board on just a regular printer just to get a size comparison to make sure that it meets what I'm expecting. Also, I don't feel like finding that again, so just spread that shear across all of our resistors. Cool, cool, cool. And all right, last guy outside of the LED is our MOSFETs, and these are SOT 363. Now I'm going to check all these later. So it's also known as an SC88. That's important to know. Okay, or 6 VSOP. Okay, I'm going to look for the SOT 363 first. Oh, here we go. Package SOT. Here we go. Love it. I'm looking for a SOT 363. SOT 363 or an SC88. All right, so no SC88. I'm not seeing a SOT. Oh, wait. Here, okay, these are not in alphabetical order. Okay. SOT 89. Ooh. Hand soldering. What kind of bad hand soldering do you think I do here? All right, I got a point of pride. I'll take the challenge. Challenge accepted. All right. First thing I'm going to do is I'm going to change this grid to something a little finer because that's insane. 1 mil will do fine. All right. So we've got... Can I do a... No. I need to do a measurement. Huh, okay. So this guy is at the 0. Yeah, he's at the 0 for the y-axis. On the x-axis, it's approximately... Why is it saying negative? It's positive down below. Yeah, it is. Weird. 0.66. Is that millimeters? It says millimeters. Okay. 0.66 millimeters. So what's the package dimensions? What are the dimensions? Oh, yeah. 0.6. All right, cool. I don't even have to do that much math. 0.65. That sounds close enough. And the distance between each pin is 2.1. So I should see negative 1.05 or something like that. Close enough. Yeah, that's close enough. That'll do it. All right. This is my guy. Copy that. Plop it down. Plop it down. Plop it down. All right, now off camera, I'm going to go ahead and make the footprint for the SPF.5 FOB. That's going to take a little while. I might make a video. I'm going to go ahead and make a video where I'm crafting that, but I've jawed on for long enough. I'm getting thirsty, getting tired, getting cranky, getting hungry. My feet hurt. Whine, 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 moan, moan, moan. You get the idea. All right, it's been a lot of fun, guys. I hope you enjoyed it. Let me get my headshot up here. Hope you guys enjoyed it. We're going to be making these schematics and stuff. These are just going to come out once in a while. You can sort of see the process, see how it's done. But it's mostly fun when you follow along or you're making your own circuits and you're figuring stuff out. I'm just going to walk you through my mental process. I hope you like these videos. hope you enjoy watching me make stuff. It gets really exciting once you start putting the circuit board together, seeing this thing come together, especially given the fact that you can have a 3D view of the circuit board and everything. That just looks really cool. I look forward to you guys joining me when I go do that. This has been the Alex Manassa, and you have a great day. Bye. Gotta find the